Welcome to the video lecture. In this video, we are going to see about multiple linear regression. Before proceeding into the topic, let me explain you what is linear regression. It is a type of supervised machine learning algorithm that is used to calculate the linear relationship between the dependent variable and the independent variable by fitting a linear equation from the observed data. So when there is only one independent feature, it is known as simple linear regression, and when there are more than one feature, it is known as multiple linear regression. Similarly, when there is only one dependent variable, it is considered as a univariate linear regression, and when there are multiple independent variables, it is known as multivariate regression. So these types can be simply expressed like this. So x and y, x is the independent variable and y is a dependent variable, as you all know. So if there is only one independent variable and only one dependent variable, it is simple linear regression. When there are more than one independent variable gives only one dependent variable, then it is multiple linear regression. In both these cases, there is only one dependent variable, hence these two comes under univariate linear regression. And when there are more than one independent variable produce more than one dependent variable, then it belongs to multivariate linear regression. So this is how we have to plot a line of regression over the data points for the independent variable and the dependent variable to obtain a best target data. So this is the line of regression, and these are the data points over which we have to fit the best regression line to get the best target data. So simple linear regression equation can be given by y is equal to beta naught plus beta 1 into x, where y is the dependent variable and x is the independent variable. Beta naught is the intercept and beta 1 is the slope, and these are the constants that can be determined from the graph. So similarly, the equation for the multiple linear regression can be given by y is equal to beta naught plus beta 1 x1 plus beta 2 x2 etc. to beta n xn, where x1 to etc. to xn are the multiple independent variables and beta 1 to beta n are the slopes of the respective independent variable. So let us start the problem, define a problem for based on multiple linear regression. So this is the data we are having to find the line of regression using multiple linear regression algorithm. So x1 here, there are two independent variable x1 and x2, and y is your target variable. So here since we are dealing with multiple independent variable, we have to use matrix format to proceed the problem. So the matrix for x and y can be derived from the given data, and the value for the matrix value for x can be formed from x1 and x2. Along with the x1 and x2, the first column will always be the bias. So the bias is always 1, so it is always 1, and x1, the values for x1 will be in the second column and the values for x2 will be in the third column. So the target value y is taken as the matrix value for y. So these are the value for the matrix x and y, and the line of regression is given by y is equal to a0 plus a1 x1 plus a2 x2. So the coefficients a0, a1, a2, we have to find these coefficients to form the line of regression. So the coefficients can be formed by using the formula A is equal to x transpose into x whole inverse into x transpose into y. So the x transpose, as you all know, it can be formed by converting the rows into columns or columns into rows. So this is your x, and the x transpose formed from x is displayed here, and after performing the matrix multiplication you get the value for x transpose x. This is the resultant matrix for x transpose x. So then we have to find the inverse of the resultant matrix. So I'll tell you how to calculate the inverse of a resultant matrix in your scientific calculator. So we are going to find a 3x3 matrix, the inverse of a 3x3 matrix. So go to the mode. Here in mode you have to choose matrix. So press 2, and then just press Shift and 4 to enter the value for the matrix. So now you have to choose the dimension, so press 1, and I'm going to give the name as A for my matrix, so I'm going to press 1, and you have to give the dimension, that is 3 cross 3 matrix, so M value for M and N, so I have to give 3 equal to 3. So it will ask you the value for each places. Just enter the respective value of your matrix. So verify the values once entered. Now press Shift and 4 and then choose matrix 3, and my matrix is A, so 1. So now it will display matrix A. So just press the inverse in your scientific calculator. Now it will give you the values of your inverse of the matrix. So just using the navigator, get the values for each place and write down the values. So this is how you can calculate the inverse of your matrix using scientific calculator. Now after getting the value from your scientific calculator, this is the final value for the given inverse of X transpose X. So after finding the inverse of the matrix, we have to multiply it with X transpose. So after performing matrix multiplication, you will arrive at the value of this matrix. So after that you have to multiply it with Y. So the matrix, the resultant matrix into Y matrix. So the final result arrived will be look like this. So minus 1.7, 3.028 and minus 0.152. So these are the coefficients of A. So the coefficients of A is given from, can be obtained from this matrix by substituting the value of A0, A1, A2 in the regression line formula. The resultant constructed model is given by Y is equal to minus 1.7 plus 3.028 x1 minus 0.152 x2. So this is your resultant regression line equation. So with this line, if you are giving any new values for x1 and x2, you can predict the value of y from the regression line. So this is how you have to create the regression line equation using multiple linear regression for the given data. Thank you for watching the video.